Hello, I am John Rouge, and I am going to be discussing the Pareto chart for my individual quality tool for PRM 613. So the Pareto chart is actually one of the 7 basic tools of quality that are described by Ishikawa in the book Guide to Quality Control. He also lists the check sheet, the graph, the histogram, the scatter diagram, control chart, and cause and effect diagram. All of these are used as tools to collect, understand, interpret, and analyze data. Today we're going to be looking specifically at the Pareto chart and some of the benefits and features of the Pareto chart, and then a few of the restrictions that the chart has as well. So the Pareto chart that we're looking at is used to identify values in a descending order. If we look at the example that we have here on the right, a restaurant had set out a customer satisfaction survey to find out what issues they were having with customer satisfaction and quality. They identified certain categories and listed those on the bottom of the chart, and then put the count of the response in descending order. So the most frequently occurring response would be on the left hand side, all the way down to the least frequently occurring response on the right hand side. And this is a clear way to show that data, makes it very easy to read to see what is the causing leading factors in the quality issue. But the chart does show 2 sets of scales. So there's an additional line on the right, or on the top, I'm sorry, in red, which is showing the cumulative percentage. So if you look at that first answer, overpriced, about 45% of the customers listed overpriced of the total amount of customers that took the survey for their satisfaction issue, their quality issue. When we add in that second category, the small portions, it takes the cumulative percentage of all the responses to about 85. So it's real clear that those two particular items were the lead factors in causing quality issues and customer satisfaction. Now, those two items represent the 80-20 rule, which is another thing that the chart highlights. The chart was actually named after Pareto, who is an Italian economist who studied a lot of the social sciences, but this chart particularly came after his studies of Italian land and property ownership. He identified that about 20% of the population of Italy owned about 80% of the land. And that 80-20 rule carried over into many different facets of life. We look at it in quality. It's been applied in a lot of different fields: healthcare, criminal justice sciences, and it's that same idea that about 20% of the cause is going to be is going to cause about 80% of the issues that you're looking at. Now, that number isn't a hard set number. It is actually somewhat arbitrary, but it's a good round number that's easy to remember and has become very popular and common to be utilized. Some other types or names that this chart goes by are the ABC chart, and again, it uses these same type of numbers where it's saying that about 20% of the attributes cause about 80% of the phenomena. Category B is the next 30% of items cause about 10% of the problems. And then finally, category C, about 50%, the majority of the items will cause about 10% of the problem. So again, you're just a lot of times identifying small sample sets that are or small categories that are causing the majority of the items. And that's the goal of the Pareto chart, is to identify those. All right, so here we're going to look at some of the uses for the Pareto chart. And some of the best uses are the ability for it to identify really quickly and easily the greatest opportunity for improvement. So you can look at this at a high level and really easily see which categories are causing the largest amount of trouble or quality issues. Um, it identifies the smallest sources which cause the most defects. So, um, it washes away all of the outliers and really drills down to exactly what is causing the highest number of defects as far as frequency. Again, this is good for high level, being able to just view exactly what it is quickly and easily. But in the next slide, we are going to look at some of the issues that the chart has, because with a clear set of data sets like this, it might be a good chart to use, but it does have some limitations when the data sets get a little bit more complicated. In the research that I was doing during the annotated bibliography phase, one of the more interesting uses that I thought was for shipping and warehouse storage. And if you think about it, that 80-20 rule, I'm sure Amazon ships a lot of items very frequently and then a few items less frequently. So when you think about how they store that, and what items they have to get to quickly and effectively and ship out every day, uh, that would be a great use for the Pareto chart, because those things that are going out every day, thousands of them, it's going to be important to have real close and on hand. And then those items that would end up on the right hand side of the chart, you might want to keep stored in the back where it's not as frequently reached. And certainly quality, it works like that as well. But there are going to be a few issues that we're going to discuss in the next chart with the Pareto, or in the next slide with the Pareto chart. All right, so in this slide, we are looking at some of the restrictions of the Pareto chart, and in the research that I encountered when doing the annotated bibliography, they all brought up several restrictions with the Pareto chart. It is a good fact or a good chart to be used with simple data sets, but when you start looking at it in more detail, there are some important things that you have to keep in mind. The first one that we have noted here on the PowerPoint is that it only addresses the quantity of defects. So it's leaving out the cost, the demand on resources, the time, and the importance of the fixes. So if you are looking at the Pareto chart and using that as your means to determine what you're going to fix, you do have to think of some other things, because um, if it's really costly to make changes, then that's going to be something that's going to have to be figured out. If the frequency is very small, I think in one of the classroom examples we were talking about, a plane. And if it is only happens once, but you have to have the wing on the plane, and there's only one time when the wing falls off, well, you know you have to. It might be more important to make sure that the wing stays on the plane rather than to make sure that the latches stay up for the food trays. So you have to look at the importance of it in the overall scheme of the project, the time that these measures and the quality improvement measures are going to take, and the effect and drain of resources that they're going to have on your project. Um, so all those factors all come together to make sure that are important when looking at actually finding solutions to problems that are addressed, and they have to be noted when you're looking at the Pareto chart, because just because something doesn't happen frequently doesn't mean that it's not important to fix for quality. The next note is that it doesn't work well when you're graphing many categories. And if you can see on the example here that we have to the right, we changed up the chart a little bit. And this is something that is graphing countries. And there are so many categories that it becomes unreadable. Even in the previous example that I was talking about, Amazon, they have so many SKUs, so many SKUs that that chart might then become completely unreadable. So it works well if you are graphing things that don't have a lot of categories, but when you start getting into items that have lots of categories, the chart might become a little bit unreadable. You also have to have a pretty good separation. If things are not following that 80-20 rule, and there are so many things, and they're all very similar, just a percentage or two apart, where they're falling on the chart. It's not going to give you real great data, real quick, easy to read data. It's going to look like the one that we have to the right here, where it's just too much. The data sets are all too close to each other. Um, One suggestion was that if you have many categories like this, you create category groups. And if you create category groups, that is going to be one solution to try and reduce the amount of categories. However, that leads us to the third problem, which is the defects in one category may hide defects in another. So if you're combining things into one group, say the Amazon example, you're taking all of the health and beauty products and putting that in one category. Well, you might be hiding some of those defects. The other thing that you might be doing too is if things have multiple defects. If they have a defect in two separate categories, then is it going to show up both times in the Pareto chart? If you look at the restaurant example, the customers may have said that they didn't like the size of the meal, but they also may have had a second problem, a second defect that they didn't list because they just checked off the first one. So defects in one category might hide defects in another, and basically that might lead to incorrect cumulative data. So you have to really take these restrictions into consideration when making your Pareto chart, reading it, and addressing the quality issues. All right, so to wrap it up, the Pareto chart is a basic tool of quality control. It's been utilized since the 1960s. It's one of the original tools that was used in identifying quality control issues. It's good for understanding data and identifying the vital few, and that's an important principle for us to know when looking at quality. However, it does have restrictions on applications, as we just looked at. It's good when you're looking at a small number of categories, things that can't be duplicated or overlapped. And you also have to take into account when planning on solutions things outside of just the number and the frequency of occurrences, such as the importance of the occurrence and the value that's going to add to the product or to the project. Um, in the research we were doing, I was doing for the annotated bibliography, one of the things that came up a lot is that with advances in technology, there are new formats and easier ways to get this same data out in clear, concise ways that are easy to read and that can help improve accuracy. So the Pareto chart is still a good tool to use. It's something to have in your tool belt. It's really great for high-level reporting. If you're doing presentations and you don't have to get into the nitty-gritty of the details. But when you do want to look at the real specifics, when you are going to be making changes and acting on quality issues, you might want to delve a little deeper. And since the 60s, obviously technology has advanced, and a lot of this data can really be looked at a lot more in depth and be sliced and diced in lots of different ways. And that's the advantage that we have now. So Pareto chart overall is an important tool, a good tool to get your project started and your quality measures started. But it's probably not the end-all be-all and the final tool that you want to use when making quality decisions. Thanks a lot.